So we have discussed the different views, different styles. Of course, there are plenty of them, and usually you don't use all of them. So somehow you have to choose some of these views. So we have to decide, the software architect has to decide which views to document and what level of detail. Defining every view has some costs, of course. First, it takes you some time. Okay? You have to allocate some person or persons to defining that view. It has, of course, also a benefit, the benefit of the view itself. It makes something explicit. So what views you choose depends on the needs of the stakeholders, plus also the resources available. If you have a limited set of resources, budget, you will not have typically that much time to describe all the views. Okay, there's some balance. Stakeholders, of course, is very important here. If we take each of these stakeholders apart, for example, project manager will be likely interested in decomposition, the use and or layer, the work assignment, of course, so how to allocate software units to hardware or the teams, the deployment, and overall purpose and constraints. So typically we can describe this in this is the diagram, the figure. At the vertical axis we have level of detail, and here are the view types. In a very abstract sense, we could say the project manager's interest is like this. Somehow a module view type, but basically allocation view type. Project manager is not interested in runtime views. Okay? If you would take the following stakeholders: end user, software architect, customer, development team. And we need to depict, so define such a figure for each of them. So, how should it look like? The architect, typically. Architect. What is the required types, view types, and the level of detail? Architect. Oh, somebody should provide an answer. Enes.
For architects, module view type.
Module view type only. The software architect. That's a complete view. Only module view type.
CNC layer. But allocation cannot be convenient for software architecture.
Can also other opinions?
You should consider all of them, but the first thing to consider is
the architect should consider all of the view types. He's getting paid for it, or she. The key role is defining architecture. So all. But it's a good remark. Typically, architect will start with defining module view type, and typically with the composition views. End users. End users. Right. No ID. End users. End user is interested in nothing. But if you would still depict something here, Module, CNC or allocation, why would you depict? Maybe allocation. You could say it's nothing but perhaps allocation. Right. So it's not that much interest. That's right. That's right. Customer. What's the difference between customer and end user? End user is the person who uses it, customer who pays it, who pays for it. Sometimes they can be the same, of course. Customer, allocation, why? To decrease the cost, etc. Development team? All? More on CNC, or development is about implementing things. What is about implementing? Module view type, right? So typically it will be more here. Development team. Development team will be like this, right? Somehow. Because they will develop. We'll use uses layered assigned components at runtime, mapping between module and CNC. How does your module map to component? If you draw the component diagram, you should show that. The interface spec and a bit on allocation view type. Not much. Customer. Not that interested in module view type, implementation or runtime, but basically in allocation. Interest in cost and progress. And will need to support the environment in which the system will run. Sorry. So mainly interested in how the system works in the desired environment. So basically allocation view type. End user, some of you said is just flat, but a bit just needs to have some slight overview of the system, how it runs on the platform and how it interacts with other software. Quite low level of detail. So you define these stakeholders, you define what their needs, okay, the level of details required, and then you produce a candidate view list. You have stakeholders, you produce the candidate view list, the required view list. And then the second step, in this step, the first step that you do is, you might have too many views, because you have several stakeholders, and you say, okay, for example, this one has maybe 13 views, whatever, but in step 1, in step 2, you can combine these views. For example, you can say, I'm going to combine decomposition, uses, and generalization. I'm just going to provide one style. Okay? You can eliminate or combine views. So this is based on, again, on the resources that you have and on the importance. Third step, you have to prioritize what to do first. So you have made a list. You say, I have to define that view, and the decomposition view is the first one. Second one, layered view. Okay? You make a prioritization. It's clear? That's it, actually. So then you go on. Besides of documenting the structure, you can also document the behavior. For that, you can use just the UML behavioral diagrams. I will just go very quickly through this. For example, this could be a section by itself, or it could be a subsection of these when you describe the diffuse. An activity diagram, most of you know. Here you show the workflow from a start point to the finish point. The purpose is to model business workflows, model operations. So besides of these views, which basically focus on static modeling, you can use some behavioral modeling. For that we can just reuse existing diagrams like activity diagram, state diagram. We can use this in the requirements analysis phase, but also in the software architecture design to depict the dynamic behavior of the architecture. The sequence diagram is another option, and the communication diagram, all of you know. So this is just, so you have the static where.
Can I ask something about activity diagram?
A question.
Yes. For example, black lines in the diagram.
That's the.
What it means?
This is a decision, so it's a transition. So in this case, it's the fill order. Then it can go. It goes to ship order, or that it's a parallel branch.
These parallel processes should start at the same time and finish at the same time, or it waits.
It doesn't depict here at the same. It just says it's parallel. Okay. So typically it's like a semicolon where you provide the processes A semicolon B, which means A after B. So there's no issue of that. So they can just, there's no causal relation between these two. That's the only meaning. Okay, but you can read this also in the UML specification of OMG. You can just download it. There they have a detailed overview. Okay, so the last, I think this was the last part, is about documenting software architecture. We have looked at the architecture modeling, and we have looked at the views and beyond approach, so we know the views. Now we are at the point where we can start documenting our architecture. Software architecture documentation, typically using these architectural views. Why do we document architecture? So we have to make it explicit, we said. How do we make it explicit? By defining the explicit views. And we can use these views in our architectural documentation. Why architectural documentation? Of course, for education purposes, to introduce people to the project, for communication, and for analysis. There are three key motivations. Architecture can be, documentation can be prescriptive, which means that it will show the guidelines how to develop the design, but also descriptive. After the system has been implemented, you have it describes the whole system. Okay. The architectural documentation consists typically of documenting the relevant views and some transview of information, which is information knowledge beyond these views. Documentation beyond views. So we have seen what the views are. Actually, are three issues: the how, what, and why. Which is not related to the views itself, but how the documentation is laid out and organized, so that the stakeholder of architecture can find the information that is necessary. Usually consists of documentation roadmap and a view template. This is beyond the views. What the architecture is, including short system overview, okay, context diagram, the way how views are related, a glossary and an acronym list for the entire architecture. Finally, why the architecture is that way, provides the background for the system, how the system has evolved, maybe the company, the organization, the external constraints, the standards that have been imposed to shape the architecture, and the rationale. So which design decisions have been made. Okay? So architecture documentation consists of views plus information beyond these views, typically this kind of information. With this knowledge, you provide your architectural document, software architecture document. There are some rules for sound documentation. You have to write documentation like any report from the reader's point of view. Avoid unnecessary repetition, avoid ambiguity. These are just general guidelines. Use a standard organization. Records rationale. Why did you describe that? It's quite important. Keep documentation current, but not too current. So your system will evolve, so your architectural documentation should also be aligned with your system, but should not be too current. That is, architecture at some time should also be stable, also related to the architectural documentation. Okay, you cannot change every day. Sometimes it should be a solid basis of knowledge. Review documentation for fitness of purpose. Typically, architectural views are defined based on the stakeholders' input, and if you write the stakeholders if you write the documentation, let it review afterwards by the stakeholders. As in particular, the sections that they are interested in. This is an example of the RUP, Rational Unified Process Template for Architectural Documentation. This is just one example. Chapter 1, Introduction. Introduction of Software Architecture Document provides overview of entire software architecture documentation. So information beyond the views. Includes purpose, scope, definition, acronyms, abbreviations, references, and overview. You could have substructure, architectural representation, what kind of viewpoints, view types you will use, the architectural goals and constraints. And then you could have a chapter for each view. Use case view, logical view, process view, deployment view, implementation view, data view, size and performance quality. See? So in this way you can structure, nicely define an architectural document. Okay, let's summarize this part about architectural documentation and views. Bottom line, there is no one structure of architecture, but multiple. We need to represent architecture from different viewpoints. We have seen Cruchton's viewpoint and UML, but views can also be organized in the views and beyond approach. Can be organized in module view type, component and connector view type, allocation view type. Every view type is further constrained by styles. That is, a style is a constrained view type. Style can have different views. Every view has a benefit and cost. What views you choose depends on the needs of the stakeholders and the resources that are available. You will need to apply this also in the architectural design project, which I will discuss now. Any questions about this part? No questions. Let's look at the project then. No questions, but first I should explain. So you have finalized the midterm project, okay, where you did the requirements, architecture requirements analysis. You did problem analysis, where you identified the key concerns. You did the stakeholder identifications. You did a thorough domain analysis, where you looked at the required domains, identified the knowledge sources, evaluate these knowledge sources, derived the knowledge concepts, and provide some conceptual architecture. First step. Second step, we will continue with architectural document, where we have architectural design. For this, you should just keep the same group, but different presenter. Okay? If you have not presented the last time, you have to present. And every student knows. The goal of final project, same goals, plus update the architecture report based on review. If you have questions, you can contact me. You have to define architectural views. You have to learn how to restructure architecture using patterns. I will explain the patterns next time. Also, the same counts for architecture evaluation. So you have to learn to systematically evaluate architecture based on scenario analysis, which is quite popular, and a critical review of the process that you have applied. Project resource, similar. Textbook, time, library, internet, course notes, project midterm report, and you can contact me. The product system, the results of midterm project is input for this project. What you have to do is first to improve the report, see the web page, extend the report with the new tasks. What are these tasks? Very concretely, you have to define a module view. In the first part, you have defined the conceptual architecture, actually the domain architecture. In this case, in this part, you have to map that to the module view. The module view, the architecture. You have to define component connector view. You have to define a deployment view. Okay. In the module view, you have to apply the pattern for gross level decomposition, pattern for relevant selected components. That's the view part, plus another part is on evaluating the architecture. I will explain this later on, based on scenarios. It's not that difficult. Okay. And there's, in the discussion, there will be this discussion section, can be 1 page, 2 page at the most, where you provide a critical review on the process that you have adopted on the synthesis-based architecture design process. What are the positive points? What are the obstacles that you have encountered? What are suggestions for extensions, improvements, motivation? 1 page, 1.5, 2 page. So this will be your project report. Sorry. We keep the original content. You have to update based on the feedback. Can be done quickly. Then there's a part on a chapter on module view, component connector view, deployment view. The module view, you have a subsection applying patterns. Then the last process is scenario-based analysis of software architecture design. This evaluation of architecture based on the module view. 1 short section on discussion, conclusions. Of course, you have to update references. Okay. So we have discussed the viewpoints. You can already start with this. We will start with explaining patterns next Monday. That's this. After that, evaluation of architecture. Is it clear? Presentations, use PowerPoint. Different presenter. Not the same. 20 minutes again. Submit presentation. At least, I said here 1 day, but at least 1 hour before. Okay, not 10 minutes or 5 minutes. I don't have time to upload it. Okay? See new guidelines on the course homepage, which will be updated tomorrow. Well, the presentation topics, these were the report, the presentation topics. You don't need to explain again the whole process from requirements, domain analysis, etc. But just a very short, maybe one slide on what your case was, or the conceptual architecture, and then start with explaining the views, module view, how you have applied the pattern, which pattern, component connector view, deployment view, evaluation, conclusion. 20 minutes. Okay, it's sufficient. Project schedule, we will have the presentation the last day of the course, 22 July. I will do the summary evaluation and so on 20 July. And maybe also consultancy, I am not sure yet. I need to check whether I can make it to finalize all the topics. Presentation plan, we reverse. First group 6, then group 5, group 4, 3, 2, 1. Attendance is again mandatory. Any questions about project? No questions? You can already start with the project assignments on architecture views. Don't wait too long. Okay? Okay? Well, thank you very much. Bye.